we are going to get a volunteer to give us an opening prayer. I have quite a number of slides, so we'll not wait that much. Can we get a volunteer to give us an opening prayer? Then we'll proceed with these slides. We are looking at vectors that we had started on last week, and we'll be proceeding with them, and we see where we can stop for this afternoon. Do we have a person giving us an opening prayer? Yes, Ruth, you can go on.
Let's pause and we pray. Father, Lord, we dedicate this lesson into your hands, and we are grateful for the provision of that and this opportunity that you've given unto us. We ask that you may continue to bless us and enable us to understand whatever we are going to learn today. We dedicate every activity we are going to do in the blood of Jesus Christ, and we pray that you may be by our side in everything. We give you everything, for in Jesus' name I've prayed. Amen.
Amen. Thank you so much, Ruth. And we are going to continue our lesson from here. And I will assume you have your pen, the calculator, and at least somewhere where to write this afternoon. And we'll be continuing from slide. I need to check. We had introduced vectors last time. And for those who are new probably in this math lesson, we are trying to polish up the Linear 3 chapters. And specifically, we picked vectors, which is the last chapter of term 1, because we believe that not every school has covered the Senior 3 book, but at least we have quite a number of schools that have entered in term 1 of Senior 3, even when they may have not finished. That's why we had not to go to term 2, but we picked vectors, which is somewhere in term, vectors is somewhere in term 2, in term 1 of Senior 3. So we picked that because we believe if this is not what you last covered, then it's going to be the first thing you're going to start in your respective schools. We looked at quite a number of work here, but allow me just straight away go to slide number 15. Number 15. Let's have our microphones closed. We looked at all these slides, that's why I'm skipping them. Slide number 15, or maybe we can start from 14 to see what was on that slide. Now, those who are coming in, your friends have been here from 2, so you don't have to distract anyone here. You come in when you close your microphone, or you don't enter completely. So I'd given an assignment in the WhatsApp group. That assignment was put earlier on in the very day. I expected people to go through the assignment and we come here and do the revision together, which many people did. But I did not receive the assignments on WhatsApp, so that one means probably was too simple. That now I'll just remove people here. Trisha, I'm going to remove you from here. Where is that, Trisha? I don't have to keep reading here. Let's close our microphones at all times. Yes, the assignment was given, and I thought you may have understood it too much that you did not submit back, or probably it was very hard that you did not submit. So what I'm going to do, I'm going to pick question number 8, and we get a volunteer to take us through this. If we don't have a volunteer completely, then I can try it from this side. Then we'll look at question 9. And if question 9 is very simple, we just proceed. Those people who are disturbing here, That is praise. I'm going to just put you to the waiting room. We may not have to keep reading for people here. Praise, just stay down there in the waiting room. Then, can we get someone to give us this number 8, if it is possible? And they wanted us to get the coordinates of t, and the people coordinates of t according to that algebraic expression that they have given us here is going to be, and this is the algebraic expression they have given us, and they are telling us that to get coordinates of t, then you must get OA plus a half of AB, and AB has not been given, and the OA that has been given, they have given us a hint of how to get AB. So you can do that by getting OA, which is 3, 4. Then you must get AB first of all. And how do you get AB? We looked at this in the previous lesson. I want someone to put up the hand to give us how to get that OT. And when you get OT, it will be in a column vector. And when you get OT to get coordinates of T, then you will have to change that column vector into coordinates. Yes, Chiravo can give us.
Yeah, to get AB, we get OB minus OA, which is 9, 2.
Are you going to write, or I have to write for you?
No, I can't annotate. I'm using a laptop.
I think even the laptop you can.
How?
How? Maybe let me try to. You're using a mouse or it is a touchpad, because the touchpad is a bit hard.
I'm using a touchpad.
Maybe. If you check up there, are you able to see annotate? Let me try to open it. Yeah, it was open. Are you able to see annotate up there? Like or down there, there is somewhere they have put annotate?
No.
Okay. If you can't see.
Mr. Masara, you have switched it off. Okay, it's now back.
It's back. You check again.
I still can't see it.
Where is that annotate? On my screen, it is up.
Okay, yeah, I'm failing to see it.
Okay, it's fine. Let me do it from this side. You're saying we will get what?
To get AB, we get OB minus OA.
To get AB, we get OB.
OB minus OA.
Minus OA.
Which is 9, 2 minus 3, 4.
3, 4.
Which will give you 6, negative 2.
6, negative 2.
So to get OT, we'll have to get OA, which is 3, 4, plus a half of 6, negative 2.
We'll have to get OA plus a half of AB.
Yes, which is 3, 4.
We have this. I think we have this as well. Yes.
Yes.
It is now what?
3, 4.
3, 4.
Plus a half of 6, negative 2.
Plus a half
of 6, negative 2.
6, negative 2.
That will be 3, 4 plus 3, negative 1.
Plus 3, negative 1.
Yes. Which will give 9, 3.
Or will give 9, 3.
Yeah, I think the coordinates of T are 9, 3.
Then the coordinates for T will be
9, 3.
9, 3. Yeah, I think that is correct. If someone has not seen any mistake in that, we'll proceed. Let's close our microphones for the last time. If you want to speak something, this is a very open floor. You just put up your hand and you'll be given chance. Yes, Sharon?
Sir, I wanted to know how she got her 9. I thought 3 plus 3, you get 6.
3 plus 3 is 6, correct. That was a mistake. And next time, don't say I want to know. You just correct straight away, because that is very obvious. This is supposed to be now 6. 6, 2, like 6, 3, like that. So what is different here is that this is a position vector, which is put in form of columns. And if you stopped here, you'll be denied the accuracy mark, or the very final mark in math is a 1. And if you're denied this, it means you'll be working out of 3. If the mark was total, which if the total was 4, you'll be working out of 3. And this could be 1. And in a scenario-based question, such a question can be asked in terms of towns A and B, and their own positions. Maybe they're using coordinates. They may integrate the coordinates are taught in senior 1. And they may integrate coordinates here. They tell you town A is at coordinate this and town B is at that. And they want you to get the position of town B. And probably they have given you that expression, and it will be a serious story of maybe about 4 lines. But then when you summarize, you come up with such coordinates. Then always make sure you get the real position of that coordinate, which is T. And when you're writing the coordinates, we don't write it in vector form. You have to write it in coordinates like that. Some people write it like this, T, then you put in bracket 6, 3. Now this one also represents coordinates, but if you get a rough examiner, you may not be given this mark because they may not see this well. I would recommend you to write it the upper one. If you write it like this, maybe you're risking that accuracy mark. It may be given. If the person marking is in the rush, then you may not get it. So can I know if there is anything? My screen is off. That was Joan. I think by that time the screen was not on. Joan, you better maybe refresh, because I can see my screen even on another device here that I'm using. So I want to encourage you to get to know whenever they have given you such a task, they want you to apply a few mathematics here. Don't always rush, you may crash with such problems. I'm going to go to the next slide, and we look at the assignment that was in position 9, and they had given us AB, and they wanted us to get the magnitude of M. So for us to get the magnitude of M, we needed to get the column vector for M, which was given by this expression. Now, such questions are picked from the question bank, and these are section A questions. You may find them, or maybe it may be twisted a little bit, because section A questions, even in the new curriculum, you'll find when they're a bit short, and they go for, if not 5, then 4 marks. So let's get familiar to such problems when it comes to vector algebra. And I'm trying to wait for someone to do for us M, and you just put up the hand and straight away start on it. Tell us how we can do it. If you can annotate, the better. If you can't annotate, I will help you write from this side. And we will not give that a number of minutes. If we can't find a person, I'm going to try it from here. That is Kenneth. Kenneth, you can go on. You're going to do what? You're going to annotate. Kenneth, you're breaking. I can't hear. Kenneth, it's a bit hard for me to hear what you're trying to say. Okay, it's fine. Then I can annotate from here. What do you want to start with? Kenneth, I can't hear you. Is there anyone who is able to hear Kenneth well? Probably. I think, Kenneth, your network is not good. Let's kindly get another person. If you get a better place, the better. Kenneth, you're not clear at all. Just get a better place and you try again. When you get to a better place, try to test your microphone and you'll be given a chance. Now, for this question, it has been given and they're telling us M is the same as A plus 2B. And they've given us A as -2, -9, like that, plus 2. 2 is multiplying B. So here you'll get -2, -9, which is like this. Then on this, you're going to add, now 2 is going to multiply the whole of this to give us 14. This is 4. Like that, sorry. Or like that. And this means M is going to be -2 plus 14, that is, I think, 12. And then this is what? -9 plus 4 is what? Someone is requesting for number 7 review. We can't go back to number 7. -9 plus 4 is what?
-5.
-5.
Yes.
And the magnitude now, at least for the small people I've seen trying to send me the work, they are forgetting to write the magnitude formula. They're writing it like this. X squared plus y squared, like that. Now this is a wrong formula. Some are using A and B like this. I think, Kenneth, I saw your work at some point. Though I'm not sure if you're the one I'm referring to, but they're writing like this. These are wrong formulas. When you're getting the magnitude, you can only be, the examiner can confirm that this is, what makes this formula correct is if you can call M the magnitude, like that. So this formula is now correct. And if you call this magnitude, it makes this formula correct. And if you just leave it like this, you're writing a wrong statement and it is mathematically wrong. So choose what to write and always write the right thing. So I'm going to get the magnitude of M. The magnitude of M is the same as the distance of M. And this is going to be 12 squared plus -5. Is a good practice for you to write -5. Then you square, don't just square a 5. Well, the negative would have disappeared, but there is always an M mark here that is given to any student who writes such a statement. There is an M1 put somewhere here. If you substitute correctly, there is always that mark. They have removed away mark from writing a formula in mathematics. When they are marking, they have removed away that formula because then students would write and stop here. A mark is only given if you use that formula correctly. That first line you put is the one they give you the method 1 mark in most cases. maybe if the marks are many, but the formula may not have any mark. If you substitute the values correctly here, it's when you'll be given that mark. So let's not always leave that mark. And this is going to be 12 squared is 144. And on this, we are going to add 25. When you add this, what is that? 144 plus 25. 100 and what?
119.
Oh, 119 again. It becomes less instead.
But where did the negative go?
The negative has been dissolved here. It was negative 5 squared.
Because negative 5 squared, you get the negative 25.
That is not true. Put in the calculator. Negative, okay, I don't want us to go behind, but then probably you have a point. Negative 5, this negative 5 squared is the same as negative 5 times negative 5. Now, can someone identify that person? Just put these people in the waiting room. You even don't have a name. The next person to go will be Kiprimo. Kiprimo, make sure you close your microphone. This is a very open class. You need to mention anything. You just put up the hand and the chance will be given to you. You don't have to just come here and speak. So a person was saying negative 5 squared is wrong. Because then that negative will be 2 of them, and the negative times the negative comes a positive. That's why we have positive 25 like that. I don't know if you're still there. Who was that? And so let's not think this is a negative. Can I get 144 plus 25? The answer is what? 169. Yeah, correct. And when you get this under root, it will be what? 169 under root. I was not checking in the chat. Ruth, you better check for me in that chat.
In that
someone is saying.
In the chat, Kiplimo is saying 13.
Okay. 13 units. Yeah, if that is correct, someone should confirm that 13. Someone should confirm. Now, this person with iPhone, I put you to the waiting room and you came back to this bus here. I'm just going to, that's the last time I'm putting you to the waiting room. You can't hear, unfortunately. But when I put you to the waiting room with this tab again, I'll just have to remove you from the meeting. There was that concern in the chat that for the magnitude, do we put an arrow? And that was from Fiona. I had not read that. Now the magnitude is not a vector. It's just the length. And in most cases, these 2 lines are enough to show us that you're getting that magnitude. And if it's a vector, probably you're getting the magnitude of a vector, which is probably AB. Then it has to remain the vector AB, like that. When you put it like that, you're showing that you're getting the magnitude of a vector AB. But when you look at our question, these vectors were already given. You see, when they give you in small letters, sometimes they put some line up down here like this to show that it's a vector. Those ones, you don't put arrows. I've already simplified it for you. Yeah, so that is 13. Someone is saying, what are we? What are we on? These are vectors. And we are just continuing with last week's lesson. Can I get some question if it's there? If it's not there, someone had requested that we go back a little to number 7. I want us to pick number 7 and we look at it before we proceed. Alvin, the answer is 19, correct? 13, correct? Then Aaron says M is 13 units, correct as well. Kenneth has 13 as well. Then Rachel, Linda is 13 as well. So the correct answer was 13. So basically that is it. And can I know if there is something I have to make clear here? If it is not there, I'm switching back to number 7. Okay. Let's go back a little to number 7 and we see. Billy, what was that? I've already cleaned the board.
Master, after getting the value of M, don't you put these strokes aside it so that it remains a magnitude?
The strokes. No,
Yes.
like if you want to put the strokes aside, then you write that the magnitude. Therefore, the magnitude,
Okay,
something
Master.
of M is that. Because now M is a vector. If you just say M is this, you're writing a wrong thing.
Okay, Master.
So number 7 is here. Someone had requested that we maybe look at number 7, but as if number 7, let me see, PQ, they want you to find the R such that R is OP, then OQ. I don't think this is having anything we need to look at that much. Who asked for number 7? Are you still on? And who wants to do for us number 7? If your hand is ready, put up the hand and we see if you can do for us number 7. I would prefer a person who can annotate on the screen such that you try to do it directly.
It was Chloe who asked for number 7.
And is this?
Yes, she's still on.
Okay, who wants to do for us? Who wants to try for us number 7? I think number 7 is a bit direct. They are testing you on how to multiply scalar with vectors. You have to multiply 3 with the position vector of OP and 1/3 with the position vector of OQ. Kenneth, just test your microphone and we see if it has improved.
Yeah, can you hear me?
Yeah, I can now hear.
Yeah.
Yes, you can go on now.
Yeah, to find
Yes,
the OR,
we
are going to first find OP and OQ from the given coordinates. Therefore,
yes.
OP is equal to -2, 3, and OQ is equal to 3, 6.
OQ is equal to 3, 6. Yes.
So we are going to substitute those the position vectors into our formula.
We are going
OR
to substitute.
is equal to.
We are substituting them here.
Yes, teacher.
Okay, that is OR is equals
3 into -2, 3, plus 1/3 into 3, 6. Therefore, OQ is equal to -6, 9 plus 1, 2.
Plus 1, 2. Yes.
OR is equal to -5, 11.
OR is equals -5.
11.
Yes, that is correct. Has anyone observed any errors in OR? You tell us such that we use it if it's having any error. Someone had already got, that was Sharon, already had -5, 11. And she was asking that that was the correct answer. Yes, that hand is up. What is it, Flo?
Teacher, on the third step, where there is 1/3 in brackets 3, 6, how do you multiply that equation?
That is going to be a third.
Just want to
Multiplied by 3. Then that will be a third multiplied by 6. It multiplies everywhere. Galax, I'll put you out of the meeting. Chloe, this one cancels with this, or you divide that 3 by that to give you 1. And this by this gives us 2. And that's why we have 1. Does that answer your problem?
Okay, thank you, teacher.
Okay. So let's continue. Kenneth, I think it has no problem. How do we get then the coordinates of R?
So the coordinates of R, I just write the position vector horizontally. I say R is equal to -5, 11.
Yes, -5, 11. Yes, correct. Those will be the coordinates of R. But I think where her challenge was, was on a division of these fractions. Yeah, this one multiplies. This is like a normal bracket, a third. Multiplying 3,6, but it has been written in a horizontal, in a vertical direction, like you can see the 3 up and the 6 down, but it doesn't stop the BODMAS application here. I mean the bracket multiplication here. So this a third has to multiply this, it has to multiply that, but you respect the column such that you still maintain it as a position vector. I can't see the slides. Arnold, the slides are on, so you better move out and come back again such that you can get a chance to see the slides. So basically that was number 7. Someone had requested that we try it out and we've just finished trying it out. Is there any question here or something I should clarify? If it's not there, I'll proceed to number. I want to proceed to number, which number was that? I don't remember. 8. Number what?
Number 10.
Number 10. Yes, they want us to try out number 10. I think 10 is still direct, like, but it has that technicality. They have told us that A, B, and C has been given, and they want you to get the length, which is the magnitude of that. Now, what I can encourage you here to do is that you get this. I want to go to number 11. That's why I'm just going to guide here. You just get the whole of this and call it to be. Let that be. Let that be. Maybe it can be M or anything, such that you say M is the same as that, then you solve, then you'll get the magnitude of M. That is one way. The other second way is that you can maintain A plus 2B, A plus C, then you get that, which will be -27, A plus 8, 10, 8, 11. This is, I think, 2 is somewhere here. Then plus 4, -5. like this. So you'll do that multiplication and get the two values here. Then you come and say the magnitude of this is going to be the same as, but this can be substituted by one letter. That's why I was saying you start by letting this to be M, such that you avoid writing so many words. Of course, when you're writing so many words, the error here is that you may write wrongly. For example, if you wrote and you missed this 2, it will not be equivalent to what is this side. And if the examiner is keen, will underline there like you're missing something there. Why can't you commit yourself at the beginning such that you avoid writing so many things? So, I can't hear the voice. I can't speak more than this. Is there anyone able to hear? Someone had said, I got 30 at the length. Someone should help us confirm if this was the length. Someone had 30. If you also got 30, we may need that to confirm. I can't do this. I want us to go to number 11 and we see what it was going to have. Chirabo had 30 as well, which confirms that number 10 is 30 units. Now we have number 11 here. Number 11, they have given us vector AB. AB also had 30. We've confirmed. So you're given AB and you've given BC. They want you to find the vector SC. Now they have given you AB, they have given you BC. They want you to get SC and you get the modulus. Now the modulus is the other name that means the length. It also means the magnitude of the vector. Who is trying this out for us?
Excuse me.
Yes, please.
I don't know whether what I did correct.
What?
I want to try, but I don't know whether what I did is correct.
Yes, you have to try.
I said that to find SC, we are going to add vector AB plus BC.
Yeah, I was trying to write a message here. Anyway, let me pick this pen. Are you able to write or I write for you?
Teacher, right?
You're saying you're just trying, you're not sure?
Yes.
Okay, go on.
I said that SC, we're going to add vector AB plus vector BC.
To get SC is the same as?
Yes. Adding vector AB plus BC.
Adding vector what?
AB.
AB plus BC.
Plus BC.
How come?
Because I did that because at that point, you said that if AB is parallel to BC with a common point B, then points ABC are collinear. That's what I added.
I beg your pardon, if AB?
If AB
is
parallel to BC, with a common point B.
With a common point B, yes.
Then points A, B, C are collinear.
Point B, C are collinear. So you're using that as the statement?
Yes, teacher.
Did you read that somewhere? I don't remember saying so.
Teacher, on one of the slides, teacher, you shared with us, it was among.
Because those points are here, let me try to pick them and see. Because what I remember, you're going to show me where you're picking it from one of these slides. It must have been somewhere here, slide 3. Is it somewhere here?
No.
No, still?
Yes.
Around here.
Teacher, objective 11.
11, yes.
If AB is parallel to BC with a common point B, then points AB and C are collinear.
Mm-hmm.
So then
You're what? You're getting stuck there.
So I don't know whether I'm. Yes, teacher. So when I continued, I get SC as.
The way you were mentioning it, you were changing this principle. You were changing that principle. You were changing this principle, and it was appearing as if the statement you had written was picked direct from this principle. I'm not saying your principle was wrong, but you've not just explained it well. What you had written, what was written, you was correct, but I was looking for the explanation. Have you remembered the explanation, or you get someone to help you to explain that, then you continue?
Let me get someone for me.
Okay. Do we have anyone who can explain that? He had written a statement here that was looking like this. SC is the same as AB plus BC. And he was trying to tell us that because the two are parallel and they have a common point B, then that is the reason he was picking this. And me, what I know, if the 2 points are parallel, then AB is supposed to be the same as, there should be a constant. It could be N, but the book says K, a constant, which is called a scalar, multiplying that. That's why I did not want to take his principle, because he was telling us a principle, but it was not meaning what he had written. Why does SC be equal to that? If someone can help us explain that. Is there any hand? That statement is correct. You just have to explain it. No hand is up here. Is someone trying it out? Okay, this is what is going to happen. Like, we know that AB, we know that AB has been given to us. And this AB is the same as OB. We want to get this expression down here, because then how can you write that this is equal to that? AB is the same as OB plus OA. And they have also given us BC, which is the same as OC plus what? OC is plus BC is the same as OC plus OB, like that. So when you get these two values, we want to relate it with this SC, but SC is the same as, maybe I should write SC up here. SC is the same as, S is the same as OC plus OA. You realize the relationship is not very clear. The relationship is not very clear, but we must look for a way of dealing away with this OB. I don't know if you're seeing this OB. And when we deal away with that OB, we shall remain with OC and this OA. Remember, this OC and OA gives us SC. So we look for all possible ways of dealing away with this OB and OB. And the only way we can deal away with these two is when we subtract. Let me see. It's a bit. Let me see, when we subtract, what do we get? When we subtract, if this is equation 1, and this is equation 2. Let me see. Is there any subtraction that can help us here? Let me see. When you subtract this, this one will go, but it will remain OA minus OC. I don't think that one can give us. Can someone try to explain this? It has to be subtracted if we are to deal away with that. Someone is trying to explain. Okay, can we close our microphone? This girl may move out. Okay, we are going to get equation 1. This equation 1. And we subtract equation 2. Like this. So when we subtract our equation 1 and 2, it will be AB, which is known, minus BC, which is known. You can see AB minus BC is that will be the same as this one. It will subtract with this to give us a 0. So we shall have OA
Excuse me, teacher.
Yes, please.
Teacher, the way you have stated the equation AB, it should be that AB is equal to OB minus OA, not OB plus OA. Teacher, one of the two has.
I think that was the mistake. Yeah, it has to be minus. Yeah, thank you for that. I was wondering why it was not giving. Let me see now. Do we now have to subtract? Let me see if it is now subtraction. We have to deal away with that. We will have to deal away with this OB and this one. So now this one means we have to add. Probably addition here can now give us. Let's try to add this, the two equations. I'm going to write the two equations down here. That is AB will be the same as OB minus OA. Then we have this minus OB. Now this OC minus OB, I'm just going to interchange. I start with OB such that it is in the same line, what I'm going to do, this is the same as negative OB plus OC, like that. And when I add them, I get AB plus BC to give us, now this is a 0. I'm trying to add these two equations. This is a 0. And then this will be negative OA plus C, like that, which can be written as plus BC to give us negative OA plus C. And negative OA plus OC is the same as OC minus OA. Praise, please let's not make noise. Now, Praise, you put your phone to talk using it. So we have stopped somewhere here. OC minus OA. And all of this is the same as AC. All of this. All of this is an expression that shows position vector AC. Like that. It is what you had tried to write here. AC is equal to AB plus BC. AC is equal to AB plus BC. I don't know who was giving us that. You can just continue from there now.
So teacher, after deriving our formula, we substitute.
This will be 9.
9, negative 7 plus negative 6, 3.
Yes, so this
Give
gives
us 3, 4. 3, 4.
Is it 4 or negative 4?
Negative 4.
Yes.
Yes. Yes.
Like that. So we are supposed to get the modulus, and the modulus is going to be it's going to be AC. This will be 3 squared plus negative 4 squared. Now this square root should be for all of it. And this is supposed to give us 9 plus 16 under root to give us, this is I think 25 under root. And our answer for the modulus will be 5 units. If you've identified any mistake here, let us know. And if you've not identified, but you're not very sure how we got anything here, let us know, such that when we switch off here, we are at the same pace. Just put up your hand, show where you've not understood. Yes, John?
On here, like 3 out of negative 4, how are we getting negative 4?
How are we getting negative 4? This is 7. This is negative 7. This is negative 7. I don't know if you've seen that negative 7.
I was seeing as 1.
Yeah, -7 was picked from here. Okay, and for us that the cork, that cork is disturbing our piece here. When you're finding the length of this, you square all over. Now, Tracy, we said the best way is to equate the whole of that, math. It's called an algebraic expression to be 1 letter. You don't have to square the one for A. You don't have to. That one is not. It gives the correct answer, but it's too long. So what I can say here is that you get the whole of that. You say let maybe M be the same as A plus 2B plus C, like that, such that you get the answer to M. Then you say the modulus for M is equals this. That is what I can suggest. I don't know if that was your concern. Trace, does that one answer your problem?
So no, so I was asking that, like, after finding, like after getting it as M, do we square A, then B and C?
No, but you
When
get
put
the
another
value of
square.
M. You'll get the value of M as maybe 2 and 5. It will just become a normal thing we are dealing with. All of this, when you add, it will give you 1 column vector. When you add all of this.
Okay, sir, I've understood. Thank you.
And then, teacher, I have not understood that AB is equals. You've not understood AB. Now, for you, you must have just come. We can't really go back. Can someone help us summarize what someone has asked in the chat? How do we, why are we using AB is equal to OB minus OA? Someone should put up the hand and quickly talk about that as I prepare the next slide. Ruth, you can go on. Meanwhile, as Ruth is talking about that, we have an assignment here. This was the last question. I was seeing people's work, but I had not seen the right answer yet. Maybe as Ruth is talking about how do we get that, probably someone should be working around with number 12. We see if we can get the answer at the same time. Ruth, you can go on.
Okay. About that very question, SC was not part of the working. I think that part was someone was asking, how do we get SC? But to find the column vector SC, we did not have to work out that whole working, though it's a good thing for us to know how it's derived. So we start with SC being equal to OC plus OA. In other words,
first hold on a little. Maybe you'll end with that. There is this, the one in the chat. Probably let me have to repost it again. Someone wants to just know a simple thing. If you're given AB, why do we write OB minus that? Have you seen that?
Yes. Okay.
Yes, then you'll end with the other one. First, help this one out.
Okay, if you're given AB, why do you write OB minus OA? So I'm going to annotate to explain that. We have this axis, an axis like this. For example, So let's take this point to be our A, a random point. Okay, let me have it down here a bit. A random point, then I call it A. And then another point. Okay, let us look for my. Okay. So so I have A here, and then another point B, which I'm going to label, and then I join it. Let's say this is our vector. So we have this as a translation A, B, and we label it, and then B equals, so someone's question is, why is OB why is it OB minus OA? Why it is so is that we looked at having position vectors. There is this up to A, this gives you OA. When you're finding a position vector, you consider the first point as O, or what we call 0, because it is originating from, okay, it's coming from the origin. And then B, the same thing from what? From the origin still. So it's this to the origin, and then this to the origin. That is why we are going to have the longest or what? Translation as OB first, then the nearest as OA. So we subtract to get what we have here. Yeah, I think that's how we can explain that one. And then the other one of how we get SC.
First, if that, I wanted to add something here. I don't know, but your diagram seems not to be so clear. I'm going to redraw her diagram here. Now, don't remove. Don't remove. Don't remove. She has something like this. Probably A here. She has B here. Now let's not speak here. I don't want any noise here. Someone is not helping me to put those people out of the meeting. Now we have this point she has put down here. I'm just going to use a different color to the origin, like this. Then she has this other one here like that. She has deleted it, but then we have the origin here, that is, she was calling O. And for us to move from A to B, it will be called the translation, which she had put for us here like that. And I tried to explain this using the Pythagoras theorem. Later on, I will also show you how that comes. And when you're given AB like this, when you're moving this in vector algebra, you start moving from the last letter. And this is B, which is here. So you get from B to the origin, and that is, let me see, you get, I mean, you start from the last, if you're writing this, you start from the first one here, which is A. If you're getting in vector algebra, we'll see, I'll draw that triangle in the next slides. You see what I'm talking about. For example, if they give you TK as your vector, when you're moving, you're supposed to start at T. And for this case, we have to start at A to the origin, like this. Then we go this other side. move here, move this other side. That is the longest path. And that is the translation that is going to give us this distance here. And in the Pythagoras theorem, that one is even easier. I'm going to show you that as well. I thought she would pick the Pythagoras theorem, but she went for this other one. So this is the path. So we are going to start with A, and it will go to the origin, then plus this other one. So this is this path is supposed to be OA. You can see it's supposed to be OA. But if we are going backward, then it will be in the negative sense, which is supposed to be now negative OA, because we are going in the backward sense. Then this other side is supposed to be now plus OB, like that. It's what she had tried to write here, but she quickly put this other one the other side. And it is not mathematically good for you to start writing negative. If I wrote, for example, negative 2 plus x like this, it doesn't look good. It looks a little weird, but it's a correct mathematical statement. But when you write it like this, it looks a little hidden if you have to write it in algebra. So we cannot write it negative OA plus OB like that. That's why we always prefer to push this OB to come number 1 because it's a plus. Then we subtract OA like that. It is the statement she has down there from that diagram she had tried to get us here. So that is where that comes from. And if you're using a path like it could be, probably it could be, I want to bring in the Pythagoras theorem. I don't know the right way I can explain that, but we have that path. If we have our vector AB like this, then you can complete this like this to give us something like a right angle. Like that. We're interested in this area. This area, which is AB, you can see AB is here. We want to derive the distance here, AB, which is this. You can call this A, and it's not good to call this A because in the formula it may disturb a little. You can call it any letter. I'm going to start by calling this A, this is B, and that is C, like that. And I'm trying to just relate this to Pythagoras theorem, assuming this is given to you, which is A and this is B. Of course, on the graph, if you draw this vector on the graph, it is easy to get this distance, the distance from here up to here. Then the distance, the vertical distance, it is easier to get if you're looking for that. So you count those boxes down, then you count these boxes. So Pythagoras theorem has it that for us to get C squared, for us to get C, then Pythagoras suggests that C squared is the same as A squared plus B squared, or A squared plus B squared is equal to C squared. And we always, and now I'm trying to get the modulus, unfortunately. This one is got when you get this other one. If you get, sorry, I was almost repeating everything we did last time. But according to what she requested for, probably this can try to explain a problem. If this can't explain, then still it is this other one here. This one I was trying to derive the distance between these 2 points. Ruth, you had started on something about AC. Maybe you can proceed from there. You want to annotate?
Okay, yes. I'm going to try to speed up. Though, okay. Mr. Masaba, in this fact, in SC, do we have in a bit of simultaneous?
I was bringing in simultaneous to help people understand, but I don't know which other one you want to give us. I wanted to look at it, but we can put it there.
I think it's still a last simultaneous. That's why most of the whole class cannot understand. Maybe
Hey,
we leave it at that.
Wait, someone, okay, you have not covered simultaneous equations.
Yes.
Sorry about that, probably, but it was a bit not simultaneous. It was a little direct. It's here.
Okay, so I repeat a little.
I repeat it again.
Let me try.
You try.
Okay, maybe. Yeah. So SC. So I'm going to be at, do I use a text?
It's okay. You can use anything.
Okay, so if we have SC, we have been told that, of course, SC, to find it, breaking it down, we start with, oh my God. Okay, we start with this last letter. So we have OC minus OA. And that is simply what this means. So we get to the point. We get to the point of breaking it down. How did we get to that? We have our first equation, -1. Sorry, negative AB, not -1. Negative AB as seen above in the question, being equal to, why is it a negative? Mr. Masaba, why did you put it as a negative?
It's not a negative.
It's not. Not a negative. So we have AB is equal to OA minus, oh my God, this is getting hard. Can it me? B minus OA.
Can I remove that minus for you?
Yes.
Okay.
And then we also have BC as OC minus OB. So when we go further to add these so that we can see if we get our SC back, we have SC again being equal to what? To OA. Is it OO? Then OA plus OC. So we continue substituting in, and we have our AB plus BC. We said it is SC. And then when you substitute, of course, this letter O minus, this O gives you 1, or I think this is 0. 0 minus OA gives you a negative OA plus an OC, which gives you your final answer as OC minus OA. Says we cannot have negative unknowns. So after having this answer, you still follow these. When you have OC minus OA, it's an automatic point for you to have this as your last letter and this as your beginning letter. So you go the other way around and this becomes your answer. Yes, I think I've tried.
Yeah, but
To
while you
derive
were remembered something, probably this was, I don't know if someone was following what you did and there is any question you would supplement if you're there, or else I want to remember something here. There is that hand up. Whose hand is that? That is your hand still, Ruth, you can put it up. Yes, this is the, this is AB, yes, plus BC. Yeah, that is what I said. But while you were doing, I remembered that you may also substitute. For those who have just come and probably you did not see what I did, that is exactly what I did. At this point, you just add, and when you add, that OB will disappear and you remain with negative OC or a negative OA plus OC, which has interchanged and has got AC. But I remembered I was trying to see what you were doing, and I thought probably we'll do it this way. I'm going to put off your screen and do some new thing here. So we have, I know probably those who followed could have seen what we did. If you did not see, then try to see here. They want us to get AC, and AC completely is not given. Like AC is not given because AC is supposed to be OC minus OA. Like that, it's not given completely. But there is an OA that is hidden here. I don't know if you can see that. There is an OA hidden here. Then there is an OC also hidden here. So you look for that OA and substitute here. Then you look for that what? OC and substitute here. And that is what I'm going to do. AB is the same as OB minus OA, like that. And I'm going to make OA the subject of the formula. Then I substitute it here. So how do I make OA the subject of the formula? I just have to take it the other side, then bring this other side. So my OA becomes, when I take this, it becomes OB minus AB. I think that is a mathematical statement, which is true. Someone check that and we see if I have to correct something there. That is the first equation. I have my OA that I can substitute here. But where do I get OB? OB is also not. And here you can even get, this is OA. I can substitute here. I need to also get OC. And OC can only be got using this, this other one, which is BC. BC is the same as OC, the one I'm looking for, minus OB, which is here. But this one needs OC. I can make the OC the subject of the formula. If I make this OC the subject of the formula, then I can substitute it here. So I take this OB the other side. So my OC will be the same as BC plus OB, like that, if this can be my temporary equation too. So I'm going to get this OC, I substitute it here. And then I'm also going to get this OA and substitute it here for me to get AC. And that is what I'm going to do. This is what I'm going to do. My AC is then going to be the same as OC is here, which is BC plus OB. The whole of this, I am now subtracting OA. Because of this negative, I have to protect my work I'm putting. I have put a bracket. This is BC. BC plus OB. Like that. I'm just substituting OC and OA. So my AC will be BC plus OB minus BC minus OB, like this. So this OB will cancel out because of the negative effect. This OB will cancel out. And my AC will remain. I don't know if that one, it's BC, sorry. I think I've made some mistake there. OC is what? BC plus OB. Then AB, sorry, there was a mistake here in this bracket. There was this mistake in this bracket. I did not substitute well here. So I put my protective bracket here. I substitute OA, which is OB. Take away A, B, like this. I'm just substituting that. So this will be minus OB plus, this is AB, like that. So because of the negative effect, OB will cancel out and I will remain with my AC as BC plus AB. And our BC is given, which is -6, 3. Then AB is also given as 9 and -7, like that. Yeah, basically that is what I can add there because I took it for granted that simultaneous equations were obvious here. But I think if you mastered what I did at first, Ruth has tried to supplement it as well, then add this as well to back up the other one. If you didn't master the other one, then this one seems a little easier. Probably that one should not keep us so long here. If there is any question, let me know. If there is no question, I think we can proceed to number 12. Is there something I have to make clear? Put up your hand and let me know. There was that Tracy girl. Tracy, does that one help you? Samanya, is she still here even? Tracy, can that help you?
Yes, sir.
Okay. So that is it. And allow me go to the last. And this is just last week's work and it's taking us a lot of time. I wanted us to talk about something different here. Now, for us to talk about this number 12, we must study something about collinear. And I took it for granted that maybe someone could have mastered how to show that points are collinear, but it was a bit hard. Kenneth tried it, I saw the other time on WhatsApp, but probably I need to explain what it means for points to be collinear. And when points are collinear, you people, any question that shows that is talking about straight line, if they want you to show that those points are on the straight line, just show the examiner that since these points are collinear, then they lie on the same line. And it is the same talk if you're talking about parallel lines, because for any 2 points to be collinear, then they must be parallel to each other. And allow me go to collinear. I want to talk about collinear when it comes to vectors, such that if time allows us, we'll come back and do number 12, when everyone is understanding what we are doing. If time doesn't allow, I'll quickly talk about a hint, because that question is very important. And maybe if time doesn't allow, then we may stretch a little into maybe 10 minutes or 5 to have that question done. Now, when we are talking about collinear points, I told you it helps us to talk about so many things. And if you confirm that your points are not parallel, if you just confirm that, conclude that the 2 points are not collinear, I will assume you know how to show that a point is parallel, because that one is even showed in our lesson objective. I'm not sure which slide was this. This is slide 19. Someone will remind me. We're on slide 19. You see, when it comes to our lesson objectives, when it comes to senior 3, we are not supposed to talk so much about the vectors that are parallel. I had to ignore that. Now, Shante, first don't write on that screen. But for those who attended the first lesson, I talked about what it means for a point to be parallel, for a vector to be parallel to the other. And someone was trying to use that knowledge to solve the other problem, which I feared that it could be wrong. This number 11, they said if a point, if AB is parallel to BC, then there is a common point B. If AB is parallel to BC with a common point B, then points A, B, and C are collinear. So if we want to show that the points are collinear, then we must write that expression you're seeing in the bracket. Get the points here, compare with the points, get the points of AB, compare them with the points of BC. Can they be factorized out? For example, the point I'm trying to explain, that number 11, it will help us a lot, even when you're going to school. AB is parallel, is only parallel if this statement is true. AB is only parallel, is only parallel to AB is only parallel to BC if there exists these points, if there exists this constant K, such that this equation is true. For example, if I have my column vector for AB as 5, 5, 3, this one is parallel to 10, 6. These 2 points are parallel to each other, because when you factorize out, I'm assuming this is AB, this is my AB, let me call it AB. This is AB, is parallel to BC, because BC has that option of me factorizing. For example, I can factorize this. I can pull out that 2 to give me 5, 3. So because there exists this common factor, which is a K, then these 2 points are parallel. So if you just establish such a statement, then tell the examiner that hence these 2 lines, these points lie on the same line, or they are parallel, or they are collinear, depending on whichever way the examiner has asked this question. Just tell, provided you establish this common factor. Now, this common factor sometimes is a fraction, like that. It could be a fraction. Sometimes it could be even a negative. Don't hesitate. If it's a negative, still pull it out and tell the examiner that these 2 points are collinear. So I'll go back to our presentation. That was slide, there's so many slides here, slide 19. And they were telling us about collinear vectors. If these 2 vectors, if you solve and you realize there is no common factor that is separating, that is helping you write the other statement I showed you, then those points are not parallel. And when they are not parallel, then they are not collinear. They are non-collinear vectors. That is number one. Two, if their collinear vectors are in the same direction, yes, sometimes the two parallel lines could be all facing the same direction. That one is also collinear. I will show you if it's facing the same direction, then the constant k is positive. If it's facing in the opposite direction, like now here, it's facing down and the other one is facing up, the constant k is a negative. It could be -2, it could be -1/2. They are collinear, but the two parallel lines are facing in different directions. So there is a statement here that is very important. In this diagram, the vectors that are parallel to the same line are collinear to each other, and the intersecting vectors are non-collinear. That statement, I saw that it had some sense if you've not understood what I've just said. So this collinear, yes, Ruth, you have your hand up. This continues. Ruth, you can go on.
I wanted an explanation, maybe using a graph, because the other rule that you talked about that says if AB is parallel to BC with a common point B, what does a common point B mean, yet these two lines are parallel?
Yet the
graph
two
explanation.
Yet the two lines are parallel. I'm trying to think of a way of how to relate the two, but then it may be clear to you if I use a vector that has 3 points, and that one is at A level. I don't want to distort the lesson a little bit. I can derive it for you when I'm using 3 points. And now if there are two, unless you have one that you want to show us. But for now, let's leave it at that point. We'll try to see what that means later on in the examples. I can't start on that now for that, but put it in mind that there must be a common point, that is B. And I really don't know how to bring it on the graph for you now. So we'll have to continue. Ruth, you want to show something about the graph?
No.
Okay, let's proceed for now. I don't want to talk about that now. When it comes to collinear vectors, there is some detailed talk about those collinear, but I'm interested in the very last one because of time. This condition is the one we prove. The condition that is down here, bullet number 4, is the one that we prove if you're given 2 points and they want you to show that they are collinear, or the question can say, show that they lie on the same line. You're given a vector P, and the vector P sometimes, a vector P can be written as this. This vector P can be written, it could be even AB, like that, but because I was not able to put that thing up here very fast, I just chose to call this P, but that one is meaning that vector AB. It could be AB, or it could be a vector that has been given to you directly in position. Then this Q could be maybe TK, it could be any vector with something up here, but I also reduced it to Q. Then when you get that scalar that exists, in other words, if you're able to factorize a value out such that the two look the same, then you would have proved to that examiner that these are collinear points, or they lie on the same line, or they are parallel. This one is trying to explain the other concept that was on slide number 4, and it was number 11. So this one can be written as AB. I'm trying to see if I can remember what was on the other slide. N multiplied by BC, like that. So something like that. So we struggle to get this value out. And you people, when you solve and you're following the steps, this value will be so easy for you to see it. And I had something here to show the directions. And if we have that vector going up, then this constant will be a plus if they are going to the same direction. And if they are going to the opposite direction, this is going to be a negative to show that they are parallel, but in the opposite direction. So if you can show that, but this is majorly a little up when you're dealing with 3 vector points. You will see that when you continue so far with math. So for now, take it that once we get that constant, then we have shown that. I'll go ahead and give a few random examples here. For example, we may have our vector AB as maybe 6, and this could be maybe 10, and our vector maybe the other one as BC, or any vector there, as this one now can be maybe which value can be here. It could be 12. It could be 12 and 5. 12 and 5. You can show that these two are collinear, because when you factorize out this, you'll get a certain constant out. Or we may have, I'm just using AB because it's the one I'm so quick at writing. You may have 10 and maybe 14. And then we have the other one as BC, which is, this could be maybe 20. And this 20 could be, yes, 20. And when you multiply 14 by 2, that is, I think, 28. Such that AB can be the same as 2 BC, something like that. Because when you put this, there is this 2, which is multiplying 10 to give you 20. And there is this 2 that is multiplying 14 to give you 28, something like that. The constant is 2. Yes, Alvin had seen that constant. Who can give us probably some 2 vectors? You can call the first vector A, then you call the second vector B, that are collinear. Provided you can see them. Just put up the hand for now. I have so many examples for those who are getting worried. We are going to see how to prove that the points are collinear. Then we shall go back to our question and see what to do with it. No one can try. This is Ruth. Which values do you have here?
4, 6.
Which one?
4 and 6. 4, 6.
Yes, 4 and 6. And this one can be?
That one is 12.
12, yes.
18.
12 and 18. And the
so
constant,
we have constant is 3.
Constant is 3.
Yes.
Such that you can write your A is the same as 3. B. You would have showed them. You would have showed that they are collinear. Because of time, I may not try that out so much. There is this question here. They have given you a question here. and they want you to show that the 2 points that they are collinear. Now, this is where we started from. For those who have been following, we started from something like this. They have given you points P, Q, and R as this respectively, and they want you to get PQ, they want you to get QR. At the end, you show that the lines are collinear or they lie on the same line. So here we start by getting our PQ, and our PQ is the same as OQ, take away OP, like this, and OQ is given as, now this is respectively, so this one is for P, this first value is for P, this one is for Q, and this one is for R. When they say respectively, don't put the R here and put the Q here, you follow the order that is this side. So OQ is the one that has 9, 2, like that. Take away OP, OP is 1, 2. And this will give us our answers, what? 8, 0. And this is PQ. Like that. We need to get QR. QR is the same as OR. Take away OQ. And our OR is 5, 2. Take away OQ, which is 1. Which is 1, 2, like this. And this will give us a 4, 0, like this. So we want to show that these two are collinear. And for those who are seeing, our N is what? For those who are following, N should be what? Who has seen that N? N is 2, the constant is 2. Yeah, the constant is 2 if you're starting with QR, but N here is a half. They are trying to, yes, it is 2, sorry. Yeah, N is 2. So how do you prove? You say that QR sorry, PQ, QR, let me see. Let me see in the chat. Okay, I thought someone had written something else. So we want to show that P, Q, and R are collinear. P, Q, and R are collinear. So we'll say PQ is the same as 2Q, R, like that. So if you're able to come up with this, then you say since this is true, then P, Q, and R are collinear. You'll come up with something like that. So these are questions that I always put in section B. They give you something like this, but they have illustrated it on maybe a triangle or probably, anyway, they can bring part.
Is it correct?
I don't know. Have you seen
I thought it's QR is equal to 2PQ.
2.
How do you see?
I don't know, because me, I'm already tired. You're saying what? Q, 2. You're saying what? Let's write that and see. Ruth, I didn't hear that. Is she still here? Ruth, you've closed your microphone.
Okay, I was asking. I thought the answer is QR is equal to
Is equal to 2P.
2PQ. It's the other way around.
No, if you want to write it this way, then you write a half. It's what I wanted to write also. It's a half P, like that. This is correct as well. If you divide through by what? If you want to make QR the subject, you divide through by these two. That's why it gives us a half. And if you put a half here, you get back to 4 and 0. Something like that. Is there any other person in submission? Because I can't now really look so much here. If there is any mistake, let me know such that we correct it and we move on. There's no hand, then we will go back to our question. There was that question that was, now these slides are so many. I'd prepared something to do with the vector algebra, but I really don't know if time will allow. Our question number 2 was given like that in the assignment. They had given us A as that, B as that. They wanted us to find the column vector AB, and they wanted OQ. Then they wanted to show that it is some good question for you if you are a very hardworking student. It's a very good. So I think QR is now Kezia. You have brought this when I've already cleaned the other side. It's hard for me now to relate your answer with what you want to say. So this is 12, and number 12 is here. And we are going to do this together and see we're going to do this together and see what the answer will look like. This 12, they have given us, they want us to find AB. AB is a bit obvious, which is OB. Take away OA, like that. This will be a 410. Take away this, negative 24. This is negative. And our AB will be, this is 6, 14. 6 what? I think this is 6, 6, 6. Like that. This is AB. Then I have got this mark if they wanted us to get. Now don't fear a question. You can even start and stop somewhere. I already have that mark because the question wanted me to get AB. Then they've given us a scenario here. If OK is 2, OK is 2, 8, like that. Find AK. Now AK, vector AK is given by O K, take away O A, like this. Then OK is given which is 2, 2, 8. Take away OA. OA is also given. OA is this one here. OA is negative 2. Negative 2, 4. Like that. And this gives us, this is what? 4, 4, 4, like that. This is A, K. And they want us to show that these points lie on the straight line. First of all, is there anything I have to explain here, or is there anything that I've made a mistake here for those who have been following? Are this true? So we have a B, we have a K, and we have to show that they are all on the straight line. Yes, 4, 4, correct. Now, how do you show that they are all on the straight line? You have to show that they are collinear. And I'm failing to relate here, AB, and AK. How can we relate here? Is there any N? Has anyone seen N here? Alvin has also 4, 4. When I pull out 3, I pull out 4. I don't seem to be seeing that. Who tried out this? Who could have tried out this? I don't know whether I've made some mistake here. N is 2. How are you getting your N as 2? That was who? Alvan, how have you got your N as 2? N is 0, it can't be 0. Someone is saying something, but it's not adding up. Show me where the mistake is. Alvan, is there anything you've seen here on the screen? Because I'm about to switch to another option. The other option, if it cannot give you that easily, you have to use the gradient of the line, the gradient of the straight line. If they tell you, sorry. This is okay now. I've seen that. I've seen where the mistake is. So we have got our, yeah, that was a good tease. We've got our AB, it has a mark, and they also told us to get AK, which gives us another mark. You can see another mark is there for AK, and they want us to show that A, comma, K, then B lie on the same line. Then if they are lying on the same line, we have to prove that AK is collinear to KB. That is what it means here. We have to prove that AK is collinear to KB. And we only have we only have AK, but we don't have what? KB. And KB, someone should help me get that KB very fast because it is OB. I take away OA, OK. And our OB is 4, 10, like that. Take away our OK. Mariam, hope you don't write there. OK, which is 2 to 8. And when you subtract KB becomes, this is 4, this will be 4 minus that, which is what? 2, and this one minus that is 2. Like that.
It's -2.
Where is -2?
Teacher, this.
Which one? Let me know.
Sir, no, it's not.
It's not. Yes, it is 2, 2, correct. It is 2, 2. And we have to show that AK is collinear to KB. AK is here, which is 4, 4. Then KB is 2, 2. And our N becomes what? Alvan has 2, 2 as well. So our N, I'm going to put it a little bit up here. What's in that N? I'm going to put it somewhere here. I'm going to compare something here. Our AK is the same as 4, 4. Then our KB is the same as, and there our N is going to be 2. For us to confirm that they are collinear, then AK is going to be 2 KB. And since that is true, we can conclude that they are collinear, and therefore those lines lie on the same, and therefore that lies on the same line. A, K, and B, they lie on the same line because they are collinear. N is 2, correct. Alvan, you had your N as 2, but you didn't tell us at first.
Okay, teacher. The first, okay, I first did it twice, and this was I did it. I first did the first method, and it was this one, though I saw you when you were doing another one. So I went by the first method you gave us. So that's how I first.
They had given you the answers too, or you just imagined?
No, teacher, I had used this same method, the one you've used now, to get to. But then when I saw you projecting, like putting another, for you when you used, you used another alternative. So I stick to your alternative.
And it was seeming not to bring. Okay, I get it. But then our N is 2. It was a bit tricky here. But then when you see that, always merge the data such that the common point is K. So okay. So I think we don't have anything we can talk more about here. But I really wanted us to talk about proportional division of a line if you're given a line, because this is the one that is going to help us so much. They are going to divide lines. They are going to draw for you something like this when you go back to your exam question papers. They are going to draw for you. Sorry, this is red and black. They are going to draw for you something like this. Assume that is straight. And they are going to draw another one like this. And they will want you to express, and probably they may put A here, B, C. And they will give you this maybe as A, and they may put for you B here. Then they may want you to express BC in terms of A and B, and our BC will be the same as you start from where they started from. They are going from B to C, then you start from here, go back, then proceed like that. So this becomes BA, then plus AC, like that. but BA does not exist, but we have AB. So this becomes negative AB, like that. The opposite direction of that, plus AC, which is correct. And this one can give us negative A plus B, like that. And this one becomes B minus A. It's a good practice for you to start writing the positive values, then you follow the negative, though it doesn't add you another extra mean. But then they are going to divide. They are going to divide. Mathematics can now become hard if they divided this line, but not in the middle, like that. And they called this probably M. They call this M. So this line BC will be divided externally. Sometimes it can be divided externally, or sometimes it can be divided internally. It depends on how the examiners set the question. But then this one, all of this is called vector algebra, and it is something that was going to come in my slides. And before we get there, we're supposed to divide a line internally, the internal division of a line. And when we are dividing, we use ratios. And those ratios, the examiners look for them so much. Unfortunately, I've deleted my slides, my annotation here. Maybe if I can put it very fast, we had something like this. Then we had another one like this. And maybe this line is dividing it here like that. Now, this is not halfway. The ratio of division of that line may be 2 to 3. If they tell you that the ratio is that, what do you do? If they tell you it is 1 to 5, what do you do? That one is division of the line, and those are proportions in most cases. So we have two types. The first one is internal, and the other one is external. So when they are dividing a line internally, this is what they do. And probably I'll just demonstrate that. For those who can take the screenshot, just take, you read about that. And then there is also external division. For example, you saw that you can see that there is A, B, and C. There is this line A, B, and there is this A, B here, but they're introducing this C. Now in the previous slide, the C was in the middle here, the one that was dividing. Hope you remember the red line. In this slide, you see that the C has been pushed out. How do you do that? That one is called external division. And this concept helps us to work out what is called the vector geometry. And in vector geometry, they ask you questions that look like this. Now, this is for beginners. They can ask you to find QR, which is a bit obvious. QR is QR. This is QR. So you start from this. This is QP, then PR. You get that. Then it's QT. There is that. But there are those questions that look like this. They are dividing that line externally or internally. So if time would allow, I would have taken you through how to divide the lines, but unfortunately time can't allow. But I want to maybe end the lesson here, but as you go back to school, because this may be the last lesson, if we see the timetable for next week, well and good. If we don't eat, then know that you may need to read more about the internal division of the line and the external division of the line. I have all of these slides. They're about 26 of them, and I'm going to share them on WhatsApp. The remaining 1 week, if you don't have to go back to your schools, then you can read through. such that you're a complete student of vectors, because vectors ends in questions that look like this. Vectors end in questions that are a little bit abstract like that. They will give you such a diagram and they'll tell you a few things, and you're supposed to use the knowledge we've been having here to solve them. And these are section B questions. Unfortunately, vectors is only taught in senior 3, but because of the lockdown and many schools have not covered, this may be pushed to senior 4. If it is pushed to senior 4, then you'll be bad off. But if it's not pushed to senior 4, then you'll have a chance to study this at an early time. And it is the external and internal division that puts off students completely. I'd given it a lot of time. I wanted us to talk about it, and for the time, I wouldn't allow. So I want to end here. Can you send the slides? Yes, I have those slides. I can send them. Probably let me leave those slides for those who can see the slides in the chat, such that you can pick them here. If you cannot see in the chat, then I will request that you maybe wait for them on WhatsApp. I've put them in the chat. They are being uploaded slowly, and you can download them directly. They are there. You can download them directly, or you can wait for them on WhatsApp. And I want to encourage you to read. If you can't read, please add that to WhatsApp. Add that to WhatsApp. Now, it's a bit hard for me to now add Medium. Let me leave a number here for you to text me that quickly. Just send me that number, Medium, WhatsApp, so that I can put it there. Then I think tomorrow we have a baking class in all classes. So you can plan not to miss it, such that you can. I want to leave this question here for those who are going to try it out. Now, this question is here. You can try it out, let me know on WhatsApp. You can post it in my inbox directly, and I can help to look at if you've done the right thing. And if you do the right thing for this, then I can go ahead and help you try to do number 2. So let's leave it here with a closing prayer. Who is giving us a closing prayer? Put up the hand and give us the closing prayer here. Yeah, if we can't find a person giving us a closing prayer, then we're going to end the lesson here, and we'll be meeting next term.
Let's humble ourselves and we pray. Father Lord, we thank you for this lesson that you've given unto us, and we thank you for all that we have learned. We ask that you may enable us to continue learning and do more practice of these very numbers, that we may get familiar with them. We thank you for our teacher. May you continue to bless him and bless all of them. In Jesus' name I've prayed. Amen.
Amen.